Alright, we're going to be talking about dot plots today, and dot plot is exactly what it sounds like. Dots that are plotted on a number line. So they are a dot plot is a visual display in each piece of data, okay, the data is just a number, okay, that is represented by a dot above each number on the number line. Okay, so for example, here's your dot plot, let's say that this is slices of pizza, okay, that these are slices of pizza eaten by students. So students, that's going to be the dot, okay, and I'm just making up something to go along with this dot plot. So there are 2 students that ate 7 slices of pizza. So if we were to make our list, okay, our list is going to be including these numbers on the number line. So how many 7s will we write in our list? Well, we're going to write 2. Okay, so we're going to make our list up here. And there's 27 numbers, so you have to write pretty small. Then we have 1 8, and we have 4 9s. So we'll write those in our list. 4 9s. And then 10s, we have 1 2 3 4 5 6. 2 3 4 5 6. 11s, we have 1 2 3 4 5 6 7. 12s, 1 2 3. And then 13s, and then 1 14, and 1 18 over here. So there's our list. So unlike a box plot, which we learned about yesterday, dot plots, we can make a list. We can find mean, median, range, interquartile range. We can find all of those things from a list. So what you notice about this is we have outliers, okay? An outlier on this is either going to be much greater or much less than the other numbers, okay? So our example on this dot plot, our outlier, okay, underline outlier, is going to be 18. So when we talk about how this is distributed here, okay, we're going to talk about what's called data distribution, and that's really what it looks like visually. When we look at it, what does it look like? Is there a peak in the middle? Is there big gaps in between 2 dots? Is it clustered somewhere? We're going to use those type of words. So when it says to describe the spread and the shape of the data distribution, we're going to use words like spread out, or you can use words like cluster, and we're going to use words like peak. All right, so the data values are spread out on this dot plot from 7 to 14. So to 18. And we're going to go from least to greatest. They're spread out from 7 to 18. Now notice there's no dots on 6, there's no dots on 15 or 16 or 17. They still are on the number line because we're counting by ones, but you are not going to put those in your list because there's no dots above them. Okay, only where the dots are, those are the numbers that are going to go in your list. So the data has a cluster. All right, cluster means they're kind of all together in a little group, has a cluster from 7 to 14 with 1 peak. Now a peak is just like a mountain peak, okay, a mountaintop. The very, very top, the peak is going to be at 11. So first off, we have another part of our notes, and it looks like this, all right, and this is just talking about what other kinds of words they might talk about when they're talking about the shape of the data distribution and how it's spread out. So we have 2 dot plots. We have A, okay, so we have one here, and how this is described is it says the data values are spread out from 3 to 7 with no outliers, okay? We don't have any dots way out over here or way over here. Also, the way it's described, the data has a cluster, okay, a group right here. It has a cluster from 3 to 7 with 1 peak right here at 5, okay, 1 peak at 5. And also one other word that you might see is symmetric, okay? Symmetric is like symmetry, So in elementary, you learn symmetry. If you cut something in half, it's going to be the same on one side as it is on the other side. And that's similar to what we're talking about now. So if something is symmetric, that means that if you kind of draw like a mountaintop, it has a peak in the middle, okay? And it's pretty much the same on this side of the peak as it is on this side. So this is what you would call symmetrical, okay? This is symmetrical. It doesn't have any outliers. It's clustered together in the middle, pretty much the middle of the number line, okay? And then you're going to have, if you have a dot plot that looks like this on B, this is how you would describe it, okay? So we notice that there's an outlier here. We notice they're clustered right here. And so the data values are spread out from 1 to 9. And the data value 1 is the outlier. Okay, that's just what we said. That's the outlier. The data has a cluster from 6 to 9, okay, see that cluster right there, all together, with one peak at 9. Now, could it have more than one peak? Sure. The data distribution is not symmetric, okay? It's not symmetric because when you try to draw this hill right here, okay, it's not kind of in the middle of your number line. Your hill is lopsided off to the side. This side of the peak is not the same as this side of the peak. And it has an outlier. So there's lots of reasons why this is not, I think they use unsymmetrical or non-symmetrical. So they might use any of those types of words to describe a data plot that, or a dot plot that looks like that. So using those words, okay, we described our dot plot. But we also can look and we see that there's an outlier over here, and we see that if we did try to kind of draw this, that this side of the peak, here's the peak, this side of the peak has a whole lot more dots than this side. So I would say that this is non-symmetrical or not symmetrical. All right, so that is just describing the spread and the shape of the data distribution with all those words. Cluster, spread out, peak, gaps. Okay, we have a gap right there. They might say something like that. Okay, I just want you to know all that vocabulary. It's pretty common sense, but I still wanted you to be able to see it. So now, what else can we do with a dot plot? Well, we have this long list here. Okay, 27 numbers. So let's count, make sure we have 27. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25, 26, 27. Okay, we're good. That's really important because everything we're about to do, if we're missing a number, is going to be incorrect. So we're going to go down here, we're going to find the mean and the median and the range. Okay, so the mean, remember, you add all the numbers together, and this line right here means to divide. So you divide by the number of values, which is basically how many numbers in the list. That's all that means right there, okay? The number of values means how many numbers in the list. How many numbers did you add together? So if we added all of these numbers up here together, we would get 289, and we're going to go ahead and divide by 27 because we added 27 numbers together. There were 27 dots on that dot plot. So 289 divided by 27 is 10 7/10, 10.7. So our mean is going to be 10 7/10. Our median, all right, what we're going to do is we are going to find the middle value. Okay, go ahead and mark this out. This is a little confusing. All right, so we're going to go back up here and we're going to find our middle value. All right, I'm going to go ahead and mark out 5 on one side and 5 on the other just to save time. I'm going to do 1, 2, 3, 4, 5 more on this side. 1, 2, 3, 4, 5 more on this side. Then I'm going to go slow down and do one at a time. And I have an odd number of numbers, so I'm going to have a perfect middle median number of 11. So our median is 11. Now the range, remember, is the greatest value minus the smallest value. So it's going to be 18 minus 7 is going to be 11. So our range is going to be 11. So when you have a dot plot, they might ask you to describe the spread and the shape of the data distribution, or they might ask you to find the mean, the median, the range, or on the back on this paper, they're going to ask you to find the interquartile range. So what we're going to do is we are going to make a list, just like we did on the front. And this says the dot plot shows the number of checkers games won by each of the 20 students in the competition. So these dots are going to be this is a student. And these down here are the number of checker games that they won. All right, so we had 1, 2, 3 students win 0 games. Now a lot of people ask, do I have to put the zeros? Yes. Those 3 students really did have a score of 0. They didn't win any games. So we have to include those in our list. So 0, 0, 0. We have 2 ones. So these are the games that we're listing. 3, 3, 3, 4, 4, 2 6s, 3 7s, 2 8s, a 9, and a 10. Now again, see how there's no dot on 5 or no dot on 2? We don't include those because there's no dots above those numbers. All right, so we're going to go ahead and find the median and the interquartile range. If you remember, the median is just the middle number, and the interquartile range, we've got to find those quartiles. So let's go ahead and find the median. Okay, I'm going to mark off. I'm going to slow down here. I'm finding the median. I'm marking off on each side. Now, notice I have 2 middle numbers. So my median is going to be in between those 2 numbers. So since my middle number is in between those, this 4 and this 4 are the actual perfect middle number. So this 4 is going to go with the first half, and this 4 is going to go with the second half. And now that I know my median is 4, I can go down here to my answer choices and say, well, my median's 4, so A is out, and so is C, because I need my median to be 4. So now we're going to find the interquartile range. So I have to find the quartiles. If you'll remember, the quartiles are, my lower quartile is found by finding the median of my first half, and my upper quartile is finding the median of the second half. Okay, so I'm going to go ahead and just mark 3 out on this side. So halfway between 1 and 3 is 2. That's my lower quartile. And between 7 and 7 is 7. So I'm going to find my interquartile range by saying 7 minus 2 is 5, which is this one right here. So on the bottom, we're talking about peaks and clusters and gaps and symmetrical. So to me, this does not look symmetrical. My cluster's not in the middle. It doesn't look like a mountain with a peak in the middle. So the peak of the data is at 5. No. The data is clustered from 0 to 2. Yes. It's in a group. The data distribution has no gaps. It has a big gap right here between the 5 and the 2. And the data distribution is symmetrical. Well, it's not symmetrical because it doesn't have the peak in the middle. This is off to one side. We have an outlier, so it's going to be non-symmetrical. So the one that best describes it, the one that's true, is B.